I think, yeah. So last week we talked about a new mechanism a mechanism that we never talked about before, for bucket sharing, across namespaces. So, uh, so what we said was, so we were talking about allowed namespaces as the current mechanism. We were talking about how we have a list of namespaces right now, um, that exists on the bucket object, that is tied to the bucket object. It comes from the bucket class and put into the bucket object when a bucket is created, and only users from the list of allowed namespaces is allowed to request access to that bucket. That's kind of the security model we follow. Um, and in order to add a new namespace, or in order to allow someone to start using the bucket from a different namespace that's not already there in the list, an admin have to get involved. So it adds that extra burden on the admin. It kind of messes with the self-serve model that we're aiming for. And so we're talking about using a selector based mechanism where an admin would just set a bunch of selectors on the bucket, a namespace selector, and any namespace that has the matching labels would be able to access the bucket, was what we said. And again, if a new namespace wants access, now the namespace needs to have that label. It's better. It's better than the admin having to add the namespace specifically, but it might still require admin intervention when either a new namespace needs to be added with the relevant labels, or a namespace needs to be revoked from the list of accessible namespaces. Um, and so go while talking about this, I don't know if someone came up with a really cool idea, which is kind of like doing decentralized bucket transfer, bucket sharing kind of mechanism, where we said, in the originating namespace, there would be some sort of mechanism to or no, in the namespace where someone wants to get a bucket from another namespace. Let's say Alice creates a bucket in namespace 1, and Bob in namespace 2 wants to access the bucket created in Alice's namespace. Bob would initiate a transfer request of some sort, and Alice would have to go approve that request. And once that happens, when both sides are in sync, the controller would go, Cozy would go and provision, or go create access for that bucket in this new namespace. This is kind of the mechanism we were talking about. And let me start by asking, is everyone able to follow what this idea is?
Yeah, and well, anyone not follow it before I make my comment?
Yeah.
Does this, is there an override where Alice can say anybody can access the bucket? In other words, what if 1,000 people want to access it? Does Alice have to approve 1,000 requests?
We'll flush it out today. I mean, there is a mechanism. It's technically possible to do. The question is, how big of a concern that is, and how do we go about doing it? Um, I think that's a really good concern. Just to be clear.
Yeah, we did talk about that last week some. I guess so. The thing that's popping into my head is we've been talking about with the original plan as if there would be an actual admin sitting around pressing buttons to cause buckets to be accessible in other namespaces, but I don't think that was ever really the plan. It would just be like for alpha, we would just leave that unimplemented.
Right.
And if you wanted to do it, an admin could do it. But I think the original plan just was trying to punt on the issue and say, well, in the future, we'll develop some mechanism where you can create some object that expresses your desire to share the bucket, and then a controller would go perform that function that we were saying the admin would have to do. So if in the original schema you had an allowed namespaces field on the bucket, it might start off empty or with just the namespace of the originator. And then if Alice wanted to make it available to other namespaces, she and Bob could create some objects that some controller could notice, and then in response to those objects and some rules being enforced, it could go change the bucket to adjust the allowed namespace so that Bob's BAR could bind to it, for example. So even in the original scheme, I think there was a plan to have some other object that would allow the individual users to self-service share. We were just planning on punting on it. And now we're talking about trying to actually solve it. And so I think in both cases, there's some object that needs to be created in both namespaces, and there's some controller that needs to do something. And maybe the exact internals of the something don't matter as much as the actual UI. So to get this right, I guess we kind of have to just define what those objects that Alice and Bob need to create are, and then sketch out what the controller will do in response to them, and fully design it. I think that might be the only way through, is to fully design it and say this is how it's going to work.
Yeah, but I'd like to take a step back, because in your description, Ben, you make it sound like Alex owns the bucket. It's her bucket, and it's her choice to decide what to do with it. And that might work fine in some clusters.
Right. I was talking about for buckets created by Cozy. Right. There's always the brownfield case of someone brings the bucket in from outside.
Yeah, Jeff, do you
bucket ownership has
Jeff,
bucket ownership has been.
Sorry, go ahead.
I'm sorry, I have a delay. I apologize to everyone. Bucket ownership has been poorly spec'd out, and we tend to think the person that created the BR is the bucket owner, and yet the driver is really the bucket owner. And
hold on. So that's been an official stance.
Unless that changed.
Yeah, so the official stance has always been, I mean, it's not just the official stance. What made most sense was the driver is the owner of the bucket, or an admin account that's delegated to the driver is the owner of the bucket.
Okay.
Okay. It sounds like we're quibbling over what owner means.
Exactly.
In my mind, what owner means is the person who is allowed to delete it or mutate it. And the vision has always been, for the greenfield case, the person who creates the BR is the person who is allowed to delete it. Therefore, that person is the owner, in my mind. And if you have one that you pull in from outside the cluster, maybe you don't even give Kubernetes the ability to delete it, then the owner exists outside Kubernetes, because Kubernetes is just a user of the bucket. That's my definition of owner. It's the entity who is allowed to delete it.
Okay, well, okay. The whole discussion, and just taking a step back, is because we want to avoid an admin step when someone from a different namespace requests a bucket. Now the question is, who gets to decide which all namespaces or who all get to share this bucket, get access to a bucket that I initiated the creation of. So let's say I create a bucket request, I end up with a bucket. Why is it, who gets to decide? Is it me, or is it the admin that gets to decide this bucket can be accessed by all these different people? So should it be me, or should it be the admin? I'm not sure what the answer should be here.
The argument I would make is, when you create the bucket in your namespace and you consume it in your workloads, you're putting your data in that bucket. And I would argue users should have custodianship of their data. Right? If I create a container and put my data into it, I would like to be the custodian of that container so that people can't just steal it. Now, if someone else creates a container and shares it with me and I put data into their container, like, that's an action that I understand the implications of, right? It's not my container. I'm putting my data into someone else's container. and container might be a bad word to use here because it has two meanings, but bucket is what we're really talking about. As long as you're doing the completely inside cozy greenfield use case, I see it very similar to PVCs. You create a PVC, it's your PVC, it's your data in the PVC. You would be very surprised if someone else could steal your PVC from you, or read your PVC without your permission. So, there is the special case of it was created outside Kubernetes and only imported so that Cozy can wire it up to your pods, but the owner remains the original creator. And that case needs consideration.
But Ben, today someone can read my PVC without my permission, right? So that works today with shared NFS or Ceph or Gluster. Anybody could read my data. It's not up to me.
But
even
that's
though I create
nice by the driver, Jeff. That's not by design of CSI.
I mean, Kubernetes will not make my PVC available to anyone else. Like, you're right that there are security holes in the whole system that allow the data to become accessible from outside the cluster. But like, there are CSI drivers that create NFS shares that are extremely secure and can't be accessed by anyone except the exact pods that are supposed to have access, because they use Kerberized NFS and all kinds of security mechanisms and strong encryption. Like, it's an implementation detail how much you lock down the actual bits. But the point is, what will Kubernetes do for you? It will not make your data available to other users.
That was my point. Kubernetes doesn't do anything that I'm aware of with PVCs, but we're proposing Cozy should do something. It seems a little asymmetric to me.
Well, so Jeff, maybe you missed the original inspiration for this discussion last week. I don't think you were here. Part of what got us talking about this was there is an effort in SIG storage to do PVC transfer across namespaces and to do snapshot transfer across namespaces. And it looks
snapshot.
Huh?
I thought it was only snapshot.
It has been scoped down to only snapshot because of race condition concerns with PVCs, but in principle, people want, if Alice has a PVC and she wants to give it to Bob, like, we would like there to be a way to do that. Implementation wise, it's hard, so it might not happen soon. And we're starting with snapshots because it has less technical issues, but ultimately, Alice should be able to hand over control of her objects to other namespaces if she wants to and the recipient wants to. There's no reason to prevent that other than the technical complexity of it. So,
okay,
I think
that's interesting.
Yeah, this feels very parallel, and that's why we started talking about, if Alice creates a bucket using Cozy in her namespace, and she and Bob agree that Bob should have access to it, or maybe Bob gets full control, maybe she just hands it over to Bob and it's not her bucket anymore. I mean, there's a few different ways you could imagine it. Like, you could have an object that Alice creates and another object that Bob creates that form a mutual agreement that they're going to trade ownership of this bucket, and then a controller could just go do whatever needs doing to make that happen. And a similar mechanism could be used for sharing with one or many users.
So is this going to be like a synchronous step, like how bucket, the certificate signing request and certificate signing?
That was another similar API that was brought up in response. And the difference with that one is certificate signing is usually an interaction between a low privileged user and a high privileged user.
I actually prefer that, but go on.
And we really are envisioning peer-to-peer operations in the storage space. Alice and Bob are both low-level users, and they should still be able to trade data back and forth with no additional privileges.
I see. Yeah. Okay. Because we don't want the admin step. So will Alice, the person who originally created the bucket, be able to restrict how Bob can access the bucket?
Well, so that was why that my specific proposal last week was that Alice would actually create the BAR with whatever BAC she wanted. It could be a full control, it could be a read-only, it could be something in the middle, kind of a BAC, and allow the BAR to bind. So it has a defined level of access that Alice decides. And then she could hand over that specific BAR to Bob so that Bob can't get more access than Alice agrees to. that was one of the proposals that we talked about
So would
last
it
week.
just show up in Bob's namespace, or would Bob have to explicitly request it?
Yeah, there would have to be something on both sides, because otherwise you have denial of service type attacks where you can just push objects into other people's namespaces that they don't want, and that's bad. So yeah, Alice would have to put something into the system, and Bob would have to put something into the system that would be some sort of a bidirectional pointer. And then once the controller saw both pointers pointing at the opposite objects, you could say, they have agreed. Now I will make the transfer happen. And in the storage space, we're contemplating a whole new specific transfer object that both sides would create, and then the object itself would jump over. Or actually, you would cause a new object to get created, because Kubernetes won't literally change the namespace of an object. So you would just end up deleting the old object and creating a new one in the new namespace that's bound appropriately, so the right thing happens. And we're envisioning both a move style transfer and a copy style transfer, and both have value for different reasons. So the idea is if that approach can have success for PVCs and snapshots, then it could have success for buckets, and that's where we were last week. Was maybe BARs should be transferable in the same way that we're envisioning for snapshots, and you just have some. The difference is we could build the transfer mechanism into the objects themselves, because we're still designing the objects, right? I could create a BAR, and it could have a field that says for transfer to namespace Bob, and I just put that in there, and then now that means that anyone in namespace Bob can just claim that BAR by name, and the transfer will be executed, so that I don't need a whole separate object just to create a BAR for the purpose of transferring to another namespace.
Yeah, how do we make this, um, what's the word for it? Portable?
What do you mean? I
Well,
mean,
is there a synchronous step involved? Does Bob have to know the name of the BAR that Alice creates in the first place?
yes, that would be that there would have to be an out of band communication, because they would have to agree on some token out of band, because there's no direct communication between namespaces in Kubernetes. So but it could be as simple as like Alice knowing the name of Bob's BAR, or Bob knowing the name of Alice's BAR, and then having them both agree that that's the one that should be transferred by annotating their respective objects with the right values. As long as there's one shared string that would disambiguate multiple parallel requests, because Alice could be in the process of transferring multiple buckets to Bob, and each one would need a different token. um,
Okay.
and
So,
rewinding all the way back to Jeff's original question, like, can this scheme work with like Alice saying, make this BAR available to everybody, so she doesn't have to create 1,000 of them if there are 1,000 consumers? Depending on how we design it, the answer is probably yes, right? There should be a way that I can create a BAR and say, this is not just for Bob, it's for all comers who want to grab it. And then all I need to do is publish, the token associated with that one. And it could just be the BAR name. And then all of the other namespaces that know that BAR name can just go, and Alice's namespace name could just go claim it and get their own BARs and start using the bucket in theory.
Would this work if the BAR had a namespace selector in it, or some way that says these namespaces
Yeah, I
are
mean, we can
allowed?
get as fancy as we want, right? You could have a simple, like, this is the namespace. You could have a wildcard, or you could go all out and make it a fancy selector thing again and say, I want to share with all the namespaces that end in foobar. And then, as long as someone's namespace ends in foobar, they can get the bucket. You could invent whatever you wanted there. It's just a question of balancing UI complexity with usability.
wait, those are the same things.
So,
But anyway,
um,
so would you also think about revoking bucket sharing? A shared bucket?
Yeah, so the idea would be, I think, if Alice created one of these for sharing with Bob, and Bob didn't claim it for whatever reason, and then Alice changes her mind, she could just delete her BAR, and then later, if Bob tried to complete the claim, it would fail because Alice had deleted her
Let's say
BAR.
Bob's already using it, and then Alice tries
Ah,
to delete it.
yeah, well, so that gets into, security issues, right? Like
Yeah.
once Bob has the bucket, like there's nothing to stop him from giving it to Charlie, right? Because it's his BAR now, and even if,
Put it this way, the best Bob can give is the credentials, and should Alice be,
well, it depends how we design it. I mean, we could design it in such a way that this, once it gets moved from Alice's namespace to Bob's namespace, Bob can then make it available to share to Charlie, if he
but
wants to.
sure, okay, I see what you mean. But okay, so in that case, should it trigger a chain of revocations where the credentials are not usable anymore?
Well, but what I was going to say is, if we tried to prevent, Bob from sharing it with Charlie,
Or
like it
using
wouldn't
it
it
at all?
wouldn't be effective because Bob, like you said, Bob can just go into the pod and pull out the credentials and share those with Charlie if he's really malevolent.
It would be
So
effective because I can actually revoke the credentials. So a client using the credentials would not be able to talk to the backend anymore.
right, but what we were envisioning was that when Alice creates her BAR,
Mm-hmm.
the regular thing will happen where the sidecar will see that it'll create a BA. A call will happen down to the driver, the cozy driver, to do a publish. Access keys and secrets will get generated and stored in Kubernetes for that BA. And then when the transfer occurs from Alice to Bob, like we don't get a second BA. Like Bob just uses the BA that Alice created. Um, so under those circumstances, if Alice deletes that BA, then yeah, everyone who has pointers to it is out of luck because they didn't get their own copies of the BA. They just got a pointer to Alice's copy. So Alice remains in control of the ultimate BA underneath that BAR because she has the power to delete it. That's actually so that's one way to do it. I think we were contemplating in the snapshot design that you would actually clone the equivalent of the B or the BA, which is called a VSC and volume snapshot content object. They were considering making a second one because they have one-to-one binding rules. And then the problem becomes that if you delete you can't revoke access to it at that point. All you can do is just delete the snapshot itself and then say it's gone. There's nothing there to access anymore. But the Kubernetes object that points to it remains, and it's just a dead pointer at that point. So
Okay,
yeah,
so I have a question. Um, uh,
what you wouldn't want to have happen is like you wouldn't want, in the case where Alice wants to share it with the world, you wouldn't want everyone who tries to gain access to get a separate BA because every BA that gets generated is a call down to the driver and a new secret key and access key to pop out. And like if 1,000 people do that, that's a lot of BAs. So it seems better, if Alice wants to make it available to the world for sharing, that they all use the same access key, secret key to do that, and she can revoke them all at once, rather than having to track some
well,
some
yeah, but there's a problem there, right? Because if I get a bucket from someone else, my bucket can be taken away from me at any point. Like someone else in a different namespace is going to affect how my workload works in my namespace.
No, you don't get the bucket. You only get the BAR.
Right, right,
The,
but the credentials can be revoked. So if
yeah,
I
yeah.
have a workload that's using the bucket, it can suddenly stop functioning because someone revoked it somewhere else. It's not under my control. They
Right. But if you don't want that to happen, then you give everyone their own. You create separate BARs and transfer them to each namespace that you need to share with, so that you can revoke them individually. You always have the freedom to do that, but you should also have the freedom to only create one BAA and share it with everyone, so that you don't have to revoke all of them individually.
maybe
If you
Alice
just
should be allowed to revoke it.
maybe Alice shouldn't.
Yeah. Once it's
Well,
transferred, it's with Bob. So because if you allow Alice to revoke it, then someone else is managing my access from a different namespace, and you don't want that, right?
m- m- yeah, I guess we could. Maybe it's possible to do both, to have both modes, to say, hey, when this gets transferred, generate a new BA for the transferee. Um, and maybe there's a mode where they just get a pointer to my BA. There are probably considerations around whether we allow many to one binding between the BAR and the BA, which I think we had been talking about doing.
Yeah, I have a quick question here. It might seem slightly tangential, but in case of PVCs and secrets, I know there's a volume provisioning secret you can give. I don't know what it's exactly called, but it's a secret that's given through the PVC, all the way into the CSI driver, which can use that secret to talk to the backend and make some requests. Um,
Yes.
was that considered like that came in later, right? Was there a
Uh, yeah. Well, yeah. The secrets were not always part of CSI, and they ended up being grafted on in a fairly ugly way. And the requirement to support secrets almost killed the proposal to do the PVC transfer, because we couldn't figure out how to handle what happens about with PVCs that depend on secrets in the originating namespace. If you just transfer the PVC but not the associated secrets, now the resulting PVC could be rendered unusable by the deletion of those secrets. But if you do transfer the secrets, you can cause a security nightmare for somebody. So
Right.
there was no good answer about what to do with the secrets, and we're still struggling with that now. And it's worse than that. Snapshots have the same flaw. Snapshots can have an associated secret, um, and you, to transfer ownership of a snapshot across namespaces may require transferring a secret too, and you have all of the same issues there. So it's a very ugly problem.
Interesting. So I was kind of going along the same lines. What if instead of transferring, we had some mechanism based on secrets? So what I'm saying is, if the driver could recognize, um, based on a secret, um, who's making the request, and then allowed that person to make the request, as long as they have the correct secrets or correct credentials. So this would be like a separate set of credentials for talking to the driver. I know it sounds confusing to call it another set of credentials, but something along those lines where, um, instead of initiating this transfer, what if you could off band get some sort of secret to request from the driver a new bucket, a new bucket, yeah. So it's just to authenticate to the driver itself, and say,
That seems overly complicated, I think. I mean, we
to
already have secrets that result in access to the bucket, and that is the actual bucket access secrets, right? Like if you share those with anyone, then they of course can just access the bucket using that secret. So like that facility is going to exist no matter what. I think what we're trying to design is a simpler mechanism that doesn't involve sharing secrets to just automate this process. The moment you involve secrets, like there's a bunch of new security problems that you have to deal with. So I think we should just say that, yeah, if you're willing to share secrets, you just go pull out the bucket access secrets yourself and start sharing them with people, and they'll be able to do, at that point you don't need cozy anymore. You have the secrets, you can access the bucket. um, but
Interesting.
if you want to stay within cozy, like we'll provide mechanisms to do these things.
Fair enough. Fair enough. Okay, let's go back to the original discussion then. So we were talking about, whether we should allow. So we were talking about having two modes, one that allows revocation, the other that doesn't. Um, and if you get into that, like, who gets to decide what modes are allowed? Is that something that will come from the bucket class?
um,
So what if
I feel like
controls?
it would be a decision for the originator or the owner of the bucket, right? Because there's that's the ND whose data is on the line. Is
Okay,
the
let's take a simpler approach. What if we said Alice cannot revoke? Let's just start with that, just
Yeah.
as a thought experiment. So if Alice just cannot revoke, if the bucket is, or credentials are passed over to Bob just has access to the bucket, and until Bob deletes the BAR himself, it's not going away. The credentials are not.
Right. And Bob can implicitly share it with Charlie and all of his other
Yeah,
friends if he
by, by,
wants to.
by copying,
Right.
yeah, bad actors can exist.
Or,
In
or transferring within using the same transfer mechanism. Once we design it this way and say Alice can't revoke it, there's no reason not to allow Bob to just transfer to Charlie using the same facility Alice used to transfer to Bob.
well, the difference is Bob is getting a new set of credentials. Charlie is getting the same old that Bob has.
Right, but what's the harm?
We want to have separate credentials per request or per
Yeah,
access.
okay, but so Alice gives access to Bob, and then Bob gives access to Charlie, and Alice can't stop either of those and either of those people from using her bucket, right? That's what is implied by saying Alice can't revoke access that she gives away, is that it can spread, out of out of her control once she gives someone else access. And if we're okay with that, like we can design it that way, but
It
it
can't really,
feels
right? I mean, like,
intuitively.
unless they're a bad actor, it can't really. Like, because an access being given to Bob, and if Bob is a bad actor, sure, he can go and share with everyone else. But otherwise, Alice would want to have control over who the bucket gets shared with. Bob
Right,
doesn't, right? I mean, like,
but as long as she can't revoke Bob's credentials, like she loses that control when she gives it to Bob.
yeah, I see. It's a weak security mechanism. What you're saying?
Yeah.
Have Alice do this, huh?
So if you care, you need a revocation mechanism, or you have to accept that once you perform the transfer, you've lost control, and there's no point in setting up limits on how far it can get transferred.
So how would this mechanism look? Let's say there's a namespace that hasn't been created yet, and Alice wants to allow anyone from that namespace to access the bucket. Would it be something like, okay? Would the transferable BAR just have like a transfer two namespaces and a selector or something like that? Someone was bringing it up.
Yeah. We could implement all of this as extensions to the existing BAR object with some optional fields. So ordinarily, when you create a BAR for yourself, you leave these fields blank. But if you're creating a BAR with the intention of transferring it to somebody, you could fill in the destination namespace field or the destination namespace selector field or whatnot, and then share the name of that BAR with the user in that namespace, and then they know your namespace name and they know your BAR name, and they can similarly construct a BAR with like a namespace from and a BAR from field, and then instead of the normal thing happening, they would get this. And exactly how the Kubernetes objects needs to look, I'm sure we could figure out. But yeah, you could do this all within the BAR with a bunch of optional fields. So you would have different styles. You'd have a BARs designed for self-consumption. You'd have BARs designed for export, and you'd have BARs designed for import. But they would all function the same in terms of after they got bound, pods can just use them, right? It'd be a question of where they're getting their source material from, and whether they can be copied or not.
Yeah, the few things that bother me are the first thing that bothers me is, I mean, I still don't know the answer. I would say it that way. Is it okay to that is it okay that once it's shared, the originator really doesn't have any more control over sharing? Because if that's the case, um, really, there's no like it's basically shared with everyone at that point, and there's no ownership anymore.
Well, so this is why revocation would be a good thing. If you also force people to decide between copy and move semantics, where copy means like they're gonna get the exact same secret and access key that I have for that BAR, and move means like they just get the whole thing themselves and mine goes away. In the first case, the deletion of mine will cause the deletion of theirs because it's using the same secret. So I have the power to revoke the thing that I copied over into their namespace. In the latter case where it's moved, I lose my pointer to it after it goes away. And so at that point, it's theirs to do with what they want, and I don't have a pointer to it anymore. If you give both of those options, you cover all of your bases, because now you can sort of decide what semantics you want based on whether you do a copy into the target namespace or a move into the target namespace. Or you could even add a third, which is a clone, right? Which would make the share with the world situation more reliable. So I could just create one, and then everyone who comes to get it will effectively get their own BA with their own access key and their own secret. The problem I worry about there is scaling, right? If 1,000 people come in and create BAs, you're gonna have 1,000 access records on that bucket that have to be plumbed all the way down to the back end. And I don't know if bucket, I don't know if bucket services support thousands of access keys and secrets. Like last time I checked, like GCS supports up to 5. And then
But no, that's not true. You can have thousands.
of S3 style access keys for a single GCS bucket.
For a I don't know about GCS, but S3, yes.
Okay. Yeah, I was gonna say, like, I don't know if this is universal. I thought that there were limits in some implementations.
I don't think so. So they use the same access credential mechanism as the so they have a unified access and authentication mechanism for for the entirety of their cloud offering. So if you can have a million key users in your GCS or Google Cloud account, you could probably do it for the buckets too.
All right, I could be misremembering. I totally will admit someone knows more than me. Don't listen to me.
Um, yeah, maybe I'll go check it up once in case I'm missing something too. But last I remember, this is how it is. At least with S3, I know this for sure. And like in Amazon, their cognito storage or user management mechanism allows unlimited number of users. So I would think that at least that much is available through IAM also. It's like it's like a user management as a service kind of offering that allows unlimited users. So you would think the same thing applies to Amazon itself. That's where I'm coming from, just logically deducing. Um,
I'm looking for the specific thing that I'm remembering.
mhm.
But the point is that at the cozy level, we could give people choices. And again, it's one of those, does adding more choices just make it more complicated, or does it make it more useful?
Well, usability aside, I mean, like just the functionality first. So this is absolutely a completely new model. Something like this hasn't been done before, but there's a good reason for it. With stateful stuff, Kubernetes is just coming around, and buckets are the most natural way to consume storage in cloud native environments, and the way we're designing it, a problem like this hasn't really come up before. So I think it's okay that something like this already doesn't exist in Kubernetes, except maybe with snapshots. It's not at least common. Um, so that was my first gut reaction. So it was just like this is very new, and I think I can get over that. My second question is, I think we can work out the semantics of how sharing gets worked, whether you can revoke or not. I think that's the smaller concern here. The bigger concern is, are we making a big enough of a difference um, between this model and just saying namespace selectors, where an admin has to come and just select a bunch of namespaces?
Well, and again, the vision isn't that an admin actually does that work. The vision is that later we add some new objects to facilitate sharing, and then the controller that manages those objects would mutate the field for you, right? That would be the actual plan if we go down the original path.
Sorry, can you repeat that? So if we go down the original path, sorry, go ahead.
Yeah, if we go down the original path, the idea is we ship a version 1.0 or version alpha that doesn't support sharing, it doesn't have any built-in support for sharing. And then the idea is we later layer that in with an additional API object to facilitate sharing. And then there's a new controller that consumes that object that does all of the work of binding and modifying your buckets for you, so the admin just has to install that controller. He doesn't actually have to sit around and edit buckets all day, right? It's just a matter of there's some bucket sharing controller that would be how we would actually do it. But that's just a punt, right? It's saying that's pushing into the future and saying we don't know how we're going to do it. We'll figure it out later. And in the meantime, an admin can do it for you. But like the plan isn't actually to have an admin involved for all time. It's just we don't know what we're going to do
I
yet.
mean, namespace selector kind of offloads, takes away some of that burden on the admin.
Yeah, I mean, if we want to try to design like a very lightweight, way of just doing it,
I think to start off, that might do, but it's good to have this solution at hand. To be honest, I really like the decentralized solution. However, I want to make sure we're not over engineering at the same time. Um, because how about this? How about we put the namespace selector approach out there, um, and see how it turns out. There is a real risk of us getting pigeonholed into that. Um, yeah, so I'm kind of asking. Let's take a poll probably. How do you think we should move forward? Because so the trade-offs are clear. Um, I'm still trying to wrap my head around um, how to go about this in terms of like which one do we choose. So on one hand, namespace selectors are not really a strong mechanism. Are we addressing that with the bucket sharing mechanism, like
yeah,
the
because you get control over what level of access is being shared on a per transfer basis.
Mhm.
You can control when different users get access. You can revoke things potentially. You can
Yeah.
you can fully hand over control. Like if I just want to delegate access away to Bob and then not have it anymore, the transfer mechanism lets you do that. Like it's fairly powerful.
Fair enough. Fair enough. Okay. Okay. And namespace selectors is, yeah, very lightweight, uh, and it doesn't even solve the problem entirely, and yeah, it's not a real security mechanism at all whatsoever. I mean, there are still flaws with this approach, specifically with the transfer approach, specifically bad actors, but other than that, not really, right? Well, actually, there are other flaws too, because you don't know how the other pods and different namespaces, other namespaces, are handling your credentials, the precious credentials. Um,
Yeah, I was gonna say, like, the person, it's your responsibility if you're Alice to know who Bob is and to know if Bob is evil or not, right? And
mhm.
to make that judgment. And once you decide to give access with your precious data to Bob, you are delegating a certain level of trust to him. It's just the question is how far do you want that to go? Like you can't share your bucket with Bob without trusting him at all. You have to trust him to some extent. It's just
Could do a certificate mechanism where, I mean, the good thing is this model we're going with gives us the flexibility to add things like a certificate where only pods from with Bob selectors get to access something like that, get to access the backend or something. I mean, with certificates, you can restrict what all IP addresses um, get access to the bucket or
but,
to a particular service.
but we'd like to keep all the control in Kubernetes in the API, right? Where
Yeah,
if for whatever reason I change my mind about giving access to Bob, then I know what to do. If I'm Alice, I can just go delete something and Bob's access will poof. It's like that's pretty easy to understand.
Hmm. All right. I to be like I said earlier, I like this approach better, but I want to hear more critiques on it. Maybe Guy should come and give us his input too. But right now I'm leaning towards the decentralized approach. Um,
Was Guy here last week to
he was
hear
here
the?
last week. He
Yeah,
had a lot of interesting. I think he was also supporting this, to be honest, um, which is a really good sign. Jeff, what are your thoughts? We would love to have your feedback on this.
I would love to see something written up so that I could see it all in front of me and think about it a little deeper.
Okay, I can do that for you. I can write up something, um, and send it over to you. Well, send it over to the group
If you, if yeah, Sid, that would be awesome if you could post a link to a Google Doc in the SIG Storage Cozy, and we could get some other eyes on it too.
yeah. Let's start doing
I can
more.
help you with it.
Yeah, for sure. Yeah, let's make it a little more formal this time. I feel like we're nearing that point where things are finally heating up again. So I think it's a good idea to add that little bit of process style thing. I don't like process in general, but in this case, what if we start saying any new big proposals that's more than just a small thing should probably go into a Google Doc that details out what it is. What do you all think? So far, we haven't been doing that. We kind of
Plus
just
one for
about it,
right.
and it was fine so far. But we should do this before we reach alpha. We should start this practice before we go alpha, because after alpha, the first thing I'm going to focus on is bringing people from AWS and GCS and Azure to start coming to our meetings regularly. Um, yeah. And once that happens, it'll be good to have had this practice already. By the time that happens, it'll be good to have had this practice already in place, rather than just kind of discussing.
sounds good.
Okay,
I
cool.
It,
agree.
and if you need help writing up the design,
Yeah,
please ping me. I think the hard decision is going to be how much flexibility, to get, do you want to have things like selectors? Do you want to support both move copy? Do you want to support clone? Do you want to support, there's all the different little nuances that you could add that will end up making the API look kind of complicated and gross. And that's not a good thing, but also not having the flexibility is not a good thing.
yeah. No, I think flexibility is more important here. A lot of Kubernetes APIs feel like they're machine APIs, not really human APIs.
Yeah.
Um, and if someone wants to, because it's a framework for building frameworks, that's how we define it, right? um, and if someone wants to like make it easier, build a controller on top of it, put your own CRD and make it better for users, uh, that's not a terrible stance, to be honest.
All
um,
right. So we're going to be biased towards adding all the little bells and whistles to the transfer function to get
but
every
maybe not
version that you
all,
might want.
but maximum flexibility, yeah.
Yeah.
Yeah, because we as the platform or the framework cannot restrict users from doing everything they need to. I
Okay.
mean, we can have an opinion on what's the right way to do it, but they should be able to do everything they want to, right? Like where I'm coming from is the other option, like namespace selectors. To me, at this point, I'm pretty convinced that doesn't really solve the problem. So from that perspective, I think it makes and it's not flexible enough for object storage vendors to provide all their services. So obviously, we're going towards this path of having more or providing more flexibility for object storage vendors to implement their object storage the way they want to, while just providing this opinion of this is the way to share them, but you're free to apply all sorts of access policies on it. We're not going to restrict you from that. Okay, um, we're almost out of time. Um,
did we cover the highest priority thing?
Yeah, allowed namespaces.
Okay.
Yeah, yeah. So the highest priority thing is actually just getting to well, for the meeting was allowed namespaces, but in general, the highest priority is uh, uh, getting the KEP through. Well, not getting the KEP through to hit alpha, and KEP is a part of that process. So we're going through another round of reviews now. I believe we are not as time constrained as we were last time. So I've rewritten the entire KEP. So Ben and I think Jeff already had a chance to go through it. So Ben, I'll paste the link again in Six Storage Cozy. It's actually the last message on Six Storage Cozy. Please take a look again and share your thoughts. Maybe I've missed something. Maybe I've explained something wrong. I don't think so, but if I have, please feel free to point it out or leave your feedback so I can improve it. Same thing goes to you, Vianney. Would really appreciate your feedback on it.
Yeah.
All right. So from my side, I'll write up like a draft version of that proposal, and Ben, I'll probably ping you to help me finish it up,
Okay.
and let's put it out there. See what people say. All right. That's it from me. Is there anything else
And
someone wants to say?
and it's just occurring to me that if we can get this transfer thing right, we can completely do away with allowed namespaces, right?
That's
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 the
what
that's
yeah,
the upside of all of this.
yeah.
Yeah.
And I
Okay.
want to have this document done before Tim's review, so we can show him, hey, we have a new proposal in place
Uh,
with allowed namespaces.
okay. Well, yeah. Tim said he's busy this week, but I expect that as of next week he might start reading it.
Yeah,
So,
so we'll get it out there before that.
okay.
All right. All right. Thank you, everyone. Let's meet next Thursday.
Thanks.
All
Thank
right.
you.
Thank you.